Hi, my name is Trupiano. This is PyMine for CSI4480 Information Security Practice. Here are our team members. We have Cameron Grant, Micah Reed, and then me, Trupiano, and I'm the team lead.
So our project objectives, we have them in ABC. So the first one was creating a portable, cross-compatible malware application that will gather, upload, and report user information to an external server for attacker consumption using Python and social engineering. The next one was making an execution of the malware agent as easy as possible for the user. And the third is making the viewing and consumption of data as easy as possible for the attacker. For the project methodology, we have the attack sequence, which is the user clicks on the phishing email link. Then the user is greeted with a box to enter their system. Next, the server obtains the password and downloads software packages. Then the user runs the Python executable. The agent installs required packages and inserts auto-run file. Then the agent sends the email to the attacker with the victim's public SSH key. And lastly, the agent starts sending data to the server over rsync, which is the passwords and screenshots.
And then we got project infrastructure. The project infrastructure, we got the Python agent. The Python agent collects user keystrokes, user screenshots, transmits the asset folder containing all user screenshots and keylog files to the G Cloud server every 30 seconds. And then we got the victim. Target OS is a Debian 10 client machine running Cinnamon desktop environment. And then we got our server, which is the Google Cloud Compute Engine, receives user data, hosts HTML/PHP dashboard to the user. And then we got the PHP dashboard, displays keylog and screenshot files to the attacker for each infected user. And then we got MailChimp, mailing engine used to send phishing messages from an authorized source, spam avoidance. More on this later in the next slides.
So as we mentioned before, the phishing email details are as below. So with the phishing email, it is sent using the MailChimp mailing service, which is an application that we use that can send out mass emails, or they can send out from a subscribing list. Just like right here, we have the 4 subscribed MailChimp mailing list, which is really pretty cool, honestly, because you don't have to ask the user technically. We just have to say that we agreed that we asked them, and then they're like, okay, we're going to put you on the mailing list. The MailChimp provides the following advantages. So it avoids spam, the formatted HTML emails in a professional authenticated format, and then the email analytics, we can tell when each victim opens the email. And then also the email pretends to alert the user that there is a revolutionary update for Linux so that they should install. So overall, it looks as if this is actually coming from somewhere that is credible.
All right, now we're going to talk about the Python agent. This is one of the core components of the project. The agent consists of 2 main files, the updater.py file and installer.py. Updater.py contains all of the application logic to capture user keystrokes and the screenshots and send them to the server. Install.py contains the bash logic to install all the required Python dependencies and libraries that are necessary to run our program, along with making all the required directories, like the crucial.sys directory inside home that houses the user screenshots and key logs to be sent to the server. So the user runs updater.py. It checks a JSON file, which is a configuration file that we made, to make sure the program has not been run on the system at all. If it hasn't been run, then it will call install.py as a sub-process thread. And install.py will do all of its duties, like creating the hidden crucial sys directory in the user's home folder. And like we said, that's the holding bin for all of the keylog and screenshot files. And updater.py uses threading to take screenshots and listen for user key input on a recurring basis, so on a never-ending basis. The script is never supposed to stop unless there's a reboot. And it rsyncs all of the captured files to the Google Cloud attack server for attacker consumption. Some challenges we encountered in the project. First challenge was making the phishing email look realistic. And also some of the email clients would not let us send emails because we weren't verified. So some of the mail servers that we tried using, like some alternatives to MailChimp, said that they would not allow us to send emails like marketing campaigns because they couldn't verify our account. And it's likely that they picked up that we were trying to send a malicious email to people. So we were able to get past the filters and the blocks with MailChimp for the most part. The next one was we had to add some steps to initiate the script run automatically because of a recent patch at the GNOME desktop environment. So GNOME is a desktop environment that's the most popular one that's installed on Ubuntu Linux. They recently patched it according to CVE 2017-14604, and the patch was the user is not allowed to run any binary executable files directly from the GUI, from the file explorer. They can only run it from the terminal. And that really derailed the development of the project for a week because we had to figure out what to do. And we ended up switching to a different desktop environment that's still very widely used on Debian, more widely used than Ubuntu. And this actually worked better for us because the user is allowed to launch binary files from the GUI. Automated installation script, making sure the user did not have to input anything into the console while the agent was installing libraries using the sudo command and using other commands that would require parameters. So for example, if we generate the SSH key and we try to send data to the server, it would ask if they want to add the server as an authenticated host to send things to. The user have to type yes or no. So we had to figure out ways to get around that. And that's just by researching the commands, making sure we have the proper parameters and syntax. So we got around that way. And then similar thing with the sudo password, passing the sudo password that we obtain from the user when they type it in our web server. We passed it to the terminal so the user can install everything and run our script as a root level administrator user.
And then we got our dashboard implementation. For this, we use PHP, JavaScript, HTML, Apache server, and CSS. And then the HTML page for the dashboard, we used a PHP function to read local file paths on the server to display the files. And then as well the file names onto the main dashboard page so we can easily differentiate them from one another. We use another PHP function to open a new HTML page that will list all the files of the attacked user's computer for the attacker in that page. We use the apache.conf file to allow those files to be in root documents so we can open each file and read them on the HTML page. So we don't have to actually go to the server to read them. We can just stay in our normal dashboard and just view them from there. As for the graphs, we use a JavaScript that reads and counts all the files in the folder that is currently displayed to give us a representation of how many types of files we've accumulated from this attack.
All right, some points of creativity of our project. The first point, and these will all be demonstrated in the demo as well. So Pastor, we created a sign-in box in HTML that looks a lot like the traditional Linux box that when you're prompted to enter passwords. So the password sign-in box for a file download on the web server, it looks just like an authentic password entry dialog box. We're gonna talk more about that later. We use the threading library in Python to constantly listen for keyboard captures. And when a user types something on the keyboard, it writes it to a file in a group. And then it also takes an associated screen capture. And so that's all done with 2 threads in our program. We used a different but very popular Linux distribution, Debian 10 with Cinnamon desktop environment, to avoid patches, vulnerabilities by the GNOME Ubuntu operating system, as we mentioned in the previous slides. The use of MailChimp to send emails and receive insights and analytics of when the users open emails, when they get infected, etc. So every time a user opens the email, we can see when they open the email and who opens our emails. So those analytics can be really helpful for an attacker. And finally, using Bootstrap 4 to create a responsive web page for the attacker to easily consume the stolen information from the user's computer.
In our experiments, we tested multiple VMs for sending data over to the server. We also tested sending to multiple mailing services like Apple, Google, and Yahoo, and seeing which folder they went to, whether it be spam, which none of them went to, super important, and promotions. We also tested the HTML/PHP login form to grab the user's password, bundle it, and zip the software package to download to the user's computer. We tested the updater.py script to fully download/update the required tools to successfully complete our data mining. We tested to see if the mined information was displayed on the hacker's admin dashboard as well. And then for our project findings, we were able to successfully create an agent that is mostly autonomous and silent in terms of functionality, and mainly relies on the user playing into the phishing email scam by using social engineering. We were able to successfully create a web server that hosts the dashboard for the attacker to access. We were able to avoid most email spam filters using MailChimp and authorized trust subscription service. We also, Linux is an overall secure operation. The distributions have some safeguards that make the accidental installation of malware agents more difficult as well.
All right, and now we're going to do a quick demonstration of our project. Okay, and now for our project demonstration, we'll hand it off to Cam, who's going to talk about our MailChimp email client.
All right, can you guys see everything?
Yep.
Okay, cool. So I'm going to start off by showing you, this is MailChimp. This is the interface that we're using to send emails. I'll start off by adding contacts. This is the feature that I was talking about before, where you can add a subscriber to your list. So we're going to add test4480@yahoo.com. And then as you can see right here, it says this person gave me permission to email them. We obviously didn't ask because we're trying to steal information from them, but they don't need to know that. So you just press subscribe. It says mission accomplished. If you go back to manage contacts and view contacts, you can see right here that they are added and subscribed. Now what this means is that if I go to campaigns, this is the email campaigns that we do. Then I go to here, I'm just going to replicate this email and load. And I'm going to edit the recipients, edit segment. Let's say if I put a random email in here, like grant@gmail.com. It's going to say this: please enter at least one valid list member. If you want to send emails, they have to be in the subscriber list. So as you've seen, I just added the test4480. So I'll add them. .com. If I build the segment, initialize and save. So I'll click save. And it's from Linux Extreme, the email that has started it all. We got our subject, we got our content. I will show the content, sorry, later. But as you can see, this is what we do. And then when I press send now, and it's out there. So if I go back to all campaigns, I can see right here that test copy 6 is sending, and we can do this thing called a view report. So I'm going to show this while it's sending to the test4480 because it takes a minute. So we can see that one recipient was sent. You can see that 0 open, 0 click, bounce, unsubscribed. We can basically see the analytics of what this email is going to consist of. It hasn't sent yet. Let me just refresh just in case. Okay. So not yet. I will go back to show some more things. So as you can see, we can see the analytics of the email. I will actually go ahead and just read the email off as it is sending, which is another cool feature that it does, is that you can look at a preview of the email. So go back to here. All right. Here it is. So this is what the email would look like. Welcome to Linux Extreme. Dear Sauron Reed, my name is Levi Martin, and I'm a beta test integrator specialist for the Microsoft Linux subdivision. And I wanted to personally thank you for being a loyal. Oh, look at that. As you can see, it was sent straight to the inbox. It did not go to spam at all. It didn't go to archives, none of that drafts. It went straight to the inbox. And when you click on it, shows the entire email. Now I'm going to go through and read it right now for you as where I left off. I wanted to personally thank you for being a loyal customer for over 5 years. We truly appreciate your business. And as a token of our gratitude, we would like to invite you to become a beta tester for our newest innovative Linux system called Linux Extreme. The picture below is merely a snippet of what the future could look like for you. And then we have the picture right here of what it could look like. The new features include the newest .NET framework 8.6, which gives you a hyper-realistic graphics, new command processor to increase your internet speeds by 400 times, and you'll have the ability to connect to the virtual world physically, giving you a fully immersive experience unlike any of our competitors. And then we have right here the steps in order to run the program. So in order to utilize the new Linux system, click on the blue button that says download here, which is on here. And after that, there are 8 easy steps. So like any installation that you do for any operational system, you won't just click a download now button and then everything is just magically here. So we wanted to make this as realistic as possible by including these steps. So 1, unzip the file. 2, right click on the updater.py. 3, click properties. 4, click on permissions. 5, check the box next to executable. We added a picture right here just so we can show them, so we can see where they are. 6, click done. 7, double click run on the script file, and then 8, click run. We have another thing right here. And then also just so that we can avoid spam or Google, Yahoo, Apple, so they won't block our emails, we put a little disclaimer in here as well, just so they know this is used for educational purposes only. And as you can see, this is a very professional looking email so that people might fall for it. And when they click on the download here button, everything will start, and I will pass it on to Sal.
Thank you, Cam. So now we're going to demonstrate the process of what the victim will experience with our agent that we created. So as you can see, this is a virtual machine that that we made. This represents the attacking machine, the machine that we are going to attack. And so I've pulled up the same Yahoo mailbox, our test mailbox. And, I read through the email. I'm a user that got tricked, and I'm really interested in this. And so I'm just going to click download. Okay. Okay, and then you see it's brought to our Google Cloud server, which hosts an Apache web server. And then it's prompting me to unlock my key, my login key ring to download the update. This is actually a very, we modeled this exactly after a traditional Linux credential box dialog that a user would usually see. We literally did this, pasted all this together with HTML and Photoshop. So the user's gonna enter their password like normal. Now in the real world, this error would not be here because this server will be linked to an official domain, registered domain with a Let's Encrypt certificate. But since we did not have a domain to purchase, we did not hook it up to a domain and install certificate authority. But in a real world implementation, the attacker would do something like that. Okay, the user entered their password to the user account. I'll enter it again just to make sure I entered it in right. I'm going to say download. All right, it's going to prompt me to open the zip file. Now, what it just did was it took what I typed in. My password is Oakland. And I typed Oakland into the keychain. I clicked download. What the server did is it grabbed my text, put it into a file, wrapped it in with all the other project files, and zipped them. And now it's prompting me to download it. So I'm going to click OK and just open it. All right, it says here are the files. It places all of the application files in a folder called files. We're going to extract it. We'll just put it in the home directory. That's what the user's supposed to do. Okay, extraction completed successfully. The user is going to click show files, all very intuitive. And then the instructions that they follow in the email, we said they had to right click on updater.py and let it run as a program. So we're going to right click, properties. Now this would be obviously the user would be looking back and forth at the email, but since we've done this multiple times, we know what to do. So we're going to say allow executing files a program, close. All right, and then the last thing the user has to do is double click updater.py and then click run. All right, you can see it created a PyCache folder because the Python is running and it's creating threads and it's putting all the cached information right here. And so now what it's doing is it's calling install.py to create an SSH key and to install all of our dependencies that we need. We use multiple Python libraries, PyInput for the keyboard listener. We use PyScreenshot to capture the screenshot files, and we obviously use the threading to make sure all of that can work together and send to the server every 30 seconds using rsync. That's why we generate those SSH keys. So I'm going to pull up my email, and you can see this would be the email of the attacker that we got an email from the system with the public key of this virtual machine. So what I'm going to do is I'm going to copy this, then I'm going to go into our Google Cloud Console, which is the console that's linked to our Google Cloud server. All right, and I'm going to edit our PyMine server. Got to wait for that. I'm going to add our SSH key into here, and I'm going to save it. All right, and then now that my SSH key is logged into the Google Cloud Platform, this machine can now send screenshots and key logged files to the server using rsync because the keys are now synced. All right, so let's just open LibreOffice Writer. We'll let that launch. All right, we're just gonna start typing. Hello, world. This is our project demonstration. I'm Sal, and Cam and Reed are here too. Demonstration. All right, so what the program did is it captured my key input, and then it packages the key log files into text files to be stored in a secret directory, actually. So the user would have to either enable hidden files or they have to use the terminal. So it's stored in a directory called crucial sys. And this directory is actually made by the installer.py file on the first run of the program. So if I ls in here, you can see we have a key logs file directory and a screenshots directory. And we're going to show what's in each of those directories later when Reed presents the dashboard. Okay. And then you can also see if we cd into our SSH folder, our test underscore key that was created by our program. And so that's what I put into the Google Cloud Console to allow everything to authenticate properly. All right. So now everything should be in the dashboard. So let's hand this off to Reed, and Reed's going to show you everything about our dashboard.
Yeah, thank you, Sal. So as the attacker, we made a simple, pretty creative interface for easy access for the attacker to go in and view and look at the logs. Any data that he deems important, he can have access to. So our dashboard is actually made with Bootstrap 4, which allows our dashboard to be actually really reactive. So you can actually open this on a phone or any size screen. So Sal, if you want to click on the next tab, the ratio size is very reactive. So you can scroll up and down and open this on pretty much any device like a tablet or anything like that. So if you want to go back to the main page. So as you can see, we have the infected users list. We'll probably have to refresh the page.
Yep. So
for the new user.
Yeah, you can see that our virtual machine is user 1. That's the user account. And so when you refresh the page.
Yep. Thank you, Sal. So when we first had the page open, we had the three users, our test dummies, that we were using this whole time. to make this project work. And in the demonstration, we had a new VM called user1, which on creation, when we downloaded those files and ran them, it gets sent to the server, and then the PHP page reads the file paths and displays them on the page for us. So when we click on the user folder that we want to view at, that VM that we were using a few seconds ago, every 30 seconds logs all the files would be displayed in this page. So we broke them in 2 sections because we only care about the keylog files and the screenshots for now. That's all we have. Whatever file, if we had more, we would break them into other sections and view them like that. So in our display page, we were able to manipulate all the files to be on document root with the apache.conf file, basically give them an alias name. So when we click on a file, we actually can view it on the HTML page. So we can view every single screenshot that Sal was doing currently, that you guys just currently saw. So you can go to like the most current one, the last thing you were just doing, probably the Word document, or yep.
And the terminal. So
you would see it, yeah. To show you that this is still working though, Sal, would you mind just go into the VM and start playing around with some more so it tricks it and new files would be uploaded? So if Sal keeps running, to prove this, that it's actually doing it, so you guys see another test example, so Sal's gonna keep typing. This program is actually still running in the background. And whenever he's done, every 30 seconds, I don't know the time close, but I wasn't counting.
We were not keeping track, but
No.
we'll just wait.
But now we'll go back to the dashboard. So we'll go back to the dashboard, reload the page that we were just in. You should see more files in the file page. So if you want to reload that page. You notice maybe like 1 or 2 more files in that page since we've been playing on the VM. And if he wants to, you're gonna open up the last known screenshot to prove that what you were just typing, which would be
5510. So see, I could get 5510.
Yeah.
I've got 5500. So, or 5510 right here. So see.
Yep. So click on, yep, that screenshot. Here's another one. It literally gets updated on real time. And then we have the keylog files, and we click on that too. It parses out every so often. So we can basically try to find what's important passwords, other passwords that we might be able to steal, and we can use it against a victim. Essentially, that's our project in a nutshell.
Yep. And as Reed said, when the user, so this is really to be used when the user would be on, for example, a gmail.com login. The screen capture would see that they are on Gmail trying to sign in. And then we go to the associated keylog file, and then you say, here, here's our wonderful demo, and you look at the screen keylog file, and then you say, okay, more test examples. So you're correlating the text with the screenshot, and you say, okay, they're in Gmail, and here's their password. Great, we have their password now. This is a great way to do password exploitation. And now, as an addendum to our demonstration, we're going to hand it off to Cam, and he's going to show you some detailed insights on what kind of analytics MailChimp can provide us. So Cam, take it away.
All right, let me share my screen. All right, can you guys see everything?
Yes.
Cool. All right, so I just want to go back to MailChimp and show you something. So as you've seen, I sent it to the test 4480 at 9:43 p.m. If I go back and go to the view report of that thing that I just sent, I can look at the analytics when the recipient was sent, and I can show you that they opened it and clicked it. And if I go down here, I can show you that they opened it last change at 9:40, and the test 4480 is the email. As you can see, they match up right here. And also I sent another test just to show you that in Google, it also went to the inbox and not the spam at all. So just So I'll show you, this is the email. It did go to the inbox. These are just some more analytics for that. And yeah, there's a bunch of other things you can do. You can do an analytics 360. You can show you that Yahoo 100%, when opens, when clicks. Just overall, MailChimp is a great way to send some phishing emails, I guess. That's all I have.
Yeah, and hopefully, you know, with this project, we can, you know, they might see this and they might make some patches to make the internet even more secure. So yeah. All right. Thank you again for everyone for watching. Have a great rest of the semester.